Let's say they say, can you have this graph which I have drawn and show that C cannot lie between 3 and 7? When they use this phrase, cannot lie, it means the Y values. I want the Y values not to be between 3 and 7. If it is from the perspective of the graph, it is quite straightforward because I can literally see that the Y here is 3, the Y here is 7, and there is nothing in between. So from a graph perspective, it is clear-cut. So they won't be so nice to say you can use a graph. Usually they will ask for algebraic, which means in the phrasing of the question, you look out for, they say using an algebraic method. It's a common phrase that they will try to ask you to have in this portion of the chapter. I give you the logic first. How do we use an algebraic method? We are going to take a horizontal line equation. Let's say we have a general horizontal line. Let's call this line as y equals to k. To solve algebraically, we want to do the following. Okay, I just write the logic on the right-hand side before we start the problem. I want to intersect y equals to k with curve C. So do you want any intersection? What does the question say? Give me the region where the y values, we don't want C to be there. C cannot lie in this range. So what you want here is we want no intersection. If you don't want any segment of the graph, means that if you intersect with the horizontal line, there's no answers. So no intersection means no solution to your graph or no solutions to your equation. This we have to recall a secondary school concept. No solutions if it's a quadratic equation. No solutions means discriminant lesser than 0. Discriminant means you check for your quadratic equation, b squared minus 4ac lesser than 0. Okay, so that is the logic that we are going for. For algebraic method, we intersect with k. Depending on whether you want intersection or not, then we set the discriminant accordingly. So let's go for a general step to solve for this problem. These are the steps I'm going to take. Let's start the solution straight away. I will say we intersect C with y equals to k. So I set k to be equals to the equation. Just go back up to check the equation. So we have x squared plus 3x minus 3 divided by your x minus 1. We do that intersection. That's my step 1. Step 2, can we force it into a quadratic equation? Rearrange. Force it to become a quadratic equation structure. I cross multiply, we get it expanded. And I'm going to move everything to one side. Let's further simplify. Let me group up the x. So do we want any solutions? What is the phrasing of the problem? The phrasing of the question says, I don't want. C does not lie. You go for discriminant negative. But if the question says, give me the range of values that C lies, it will be discriminant positive or equal to 0. In this example, we will then code for no solutions. We don't want any intersection because they say cannot lie. You can set your b squared minus 4ac to be negative. Let's substitute the values. A, B, C refers to the coefficients. So b squared means 3 minus k squared minus 4ac lesser than 0. First part, let's expand. We can get this equation nicely factorized. Okay, so to solve for this, we can draw a number line. You have 3 and 7. Remember your quadratic inequality. If you want this lesser than 0, we are drawing this quadratic graph. And I'm looking for the bottom segment that is negative. So your k value would be in between 3 to 7. But you should give a conclusion. What does this k refer to? So we are saying, therefore, curve C does not lie between 3 and 7. Okay, I also want you to know that it's an optional change to k. I was intersecting with y equals to k, but this is optional in the sense that you can leave as y. If you had kept this k as a y, what it will eventually just mean is that the last line here, you also will get y to be between 3 to 7. It will still work the same way. It's just like an alphabet change. But for understanding on the logic, you should think about intersecting with a horizontal line and you want no intersections. Okay, you continue with the question. I think most of you were sketching that graph. Part 2 of that problem is going to be something like this.